Hello guys, welcome back to another video of Kubernetes series. In this video, we will discuss architecture of Kubernetes. We'll start with what cluster is and then we'll move towards the nodes in our cluster, the master node and the worker nodes. So let's get started. We'll start with what the cluster is. A cluster is, in very short, a group of machine in which your containerized application will run. A cluster is a group of compute, storage, and network resources that Kubernetes join together to run your containerized application. Or in simply, it is a group of machine which will run your containerized application. Okay, so we have two plane, or you can say two nodes. One is the control plane, which is also called a master plane or a master node. It is like a boss which will manage and governs the Kubernetes environment as well as the nodes below it, or you can say the worker nodes where your containerized application is supposed to run. And then we have the worker node. It is here where your containerized application will actually run. A node is just another word for a computer server. When you containerize your application, and that containerized application will run inside this worker node, right? We will deep dive into each node now. This is a Kubernetes cluster, as it can be seen that, and we have the control plane, or you can say the master node, and we have the worker nodes as shown here. So we will discuss each component, each node in a very detail. So let's get started. In a control plane, we have the kubectl command in which we will interact with the kube-api server. Then we have the scheduler, etcd, and controller. These are the components for the control or master plane. So what the kube-api server is, the kube-api server is just a gatekeeper. It is where the end users or other work node will use to communicate with the master node. So the kube-api server is used to expose the Kubernetes API. In fact, it's just a gatekeeper. All the communication is done through this API, and within the cluster, it is the central hub that all other components use to communicate through, like all other worker nodes, or you can say where your containerized application is running, is supposed to communicate with this. And from outside, like a end user will interact with the cluster via the API server using the kubectl command line tool. So a kube-api server, in short, is a gatekeeper where the end users or other worker nodes will use to communicate with the control plane. Then we have the etcd. Etcd just like a database where the information about your cluster is stored in key value pair. So etcd backing store is used to store the entire configuration of your cluster. It will it will have the information on what the current state of your application is and what the desire should be. So because this is critical, so what you need, you this can only be accessible via the API server, and it is recommended that you should have 2 to 3 replicas for your production environment. So in short, Kubernetes is etcd is a database which will store the configuration of your cluster in the form of key value pair, like how many pods are running and what the new state should be. Your application is running with one pod, and end user requested that there should be 2 pods. So the current state is stored at 1 and the desired state is 2. So it will store all your information about your cluster. Then we have the scheduler. So what the scheduler is doing, the scheduler works with the API server to handle all the scheduling or placement of workload across all the nodes and make sure everything is in its proper spot. So the scheduler will, what the scheduler will do, like there is you can say difference between the current state and the desired state. So the scheduler will look into the worker nodes where the pods are deployed, and it will find a place where to deploy a new pod. So this is what scheduler do. It has the information about what resources are available on each node, like what is running on each node and what is the capacity. So based on that, it will find a suitable place for your pod to deploy it on which node on which pod. It will then use the information when a deployment is submitted to decide where to place the requested pods. It is not just looking for where there is capacity, it also takes in account things like affinity and anti-affinity as well. So these are what scheduler is doing. Then we have the controller. Controller will use to control to track the state of various cluster items. It will communicate with the API server to get the desired state. Like a user requested that we need to update 2 pods, so it will communicate with the API server and will get the desired state, and then it actually state differs at all. It will take whatever action are needed to achieve that desired states. So controller will make sure that the actual state is exactly equal to the desired state. So for example, initially you have one pod or one container is running, and a user requested that hey, I need 2 containers. So the controller will make sure with the help of API server to achieve this. The actual state and the desired state should be matched. And let's now move towards the control plane workflow or the master plan workflow. So let's say you wanted to increase the compute power of your application by adding 2 new instances. So for example, I have one instance running on my worker node and I wanted to add 2 new instances. So what I will do, I will just update the configuration file. We will discuss this how you can update your configuration file. Then you will use the kubectl command line tool to upload the updated file to the API server. The API server then send this information to etcd database as the new desired state. The etcd has the current state stored, and also when it gets this information it will say, I see that there is a difference between the current state and desired states, because initially it was one state and now it is updated that hey, I need 2 more instances as well. So there is a difference between the new state and the, you can say, the desired state, the current state and the desired states. Then we will send this information back to the API server. The you can say that the configuration is updated on the API server and there is a difference, so the API server will get that information back from the etcd database. Then the API server will then in turn communicate to the scheduler that we'll need to find spots for these new replicas. So the scheduler is responsible for finding a suitable place where there is a capacity to deploy these 2 new instances. Then the scheduler will look at all the nodes and say, okay, I see here that there is a capacity for new instances, and over here on this node is some space for other instances as well. So scheduler finds a place that hey, you can place your you can say your 2 instances on X node. So this placement information is then sent through API server to the controller. Then that information, like scheduler will send that information back to the controller through API server, who is then responsible for making sure that your current state is equal to the desired state, and then you will go ahead to deploy these 2 new instances in the spots where the scheduler designated. So that was the workflow, how the control plane will look. Let me just summarize this again. So when you have, for example, one instance running and you just update that you need 2 more instances, so you will update the configuration file, and that configuration file is sent to the etcd with the help of API server, because you will communicate with the API server using kubectl command. Then there is all states stored that hey, I was having one instance initially and you requested for adding 2, so there is a difference between these two. Then the API server will ask the scheduler to find a slot in the worker node where these 2 new instances should be deployed. Then the scheduler will look for a spot. When the scheduler finds a spot, then through API server this information is sent to the, you can say, the controller, where controller will look and make sure that the current state is equal to desired state, and will go ahead and deploy your instances to the designated spots. Now in the worker node side we will discuss each step, and then we will also look into the workflow, how work nodes working. So here in a work node, we have containerized application actually running. This is the work node where actually our application will running, and we will have the kubelet, kube-proxy, docker runtime, pod, and container. So let's discuss each one by one. The first thing is kubelet. So what the kubelet is? Kubelet is just like an agent for the worker node, which allows it to be running on Kubernetes. It is the component that communicates with the control plane via API server to see if there are any state changes scheduled on the node. So it is just agent that is running on the worker node, and the API server will communicate with this kubelet that hey, we need to, you can say that instances should be placed on the worker node. So kubelet is the agent where API server will communicate with this. Then the kubelet will also monitor the node to make sure that the containers that are supposed to be running on it are healthy and up and running. So this is also what Kubernetes kubelet does on the worker node side. Then we have kube-proxy. So kube-proxy is content network interface card. It has the CNI which configures the network, provisioning IP addresses and maintaining connectivity to multiple hosts. In simple, kube-proxy assigns IP to pods, not containers. It will assign IPs to pods. What pod is? Pod, I will discuss this in later as well, but pod simply is a wrap up around your container. Your container will actually run inside a pod. So just for now, keep it that in mind. So it will assign an IP to your pod. The kube-proxy runs on each node to handle routing and load balancing for local cluster network traffic as well as for internal or external. So kube-proxy, besides providing IP to pods, it will also look into the load balancing rule as well. Each node has a unique IP address, and that is maintained by the kube-proxy. It also helps the pods and services running on nodes by updating the local IP table and firewall rules. So if a pod is unavailable, the node's routing information knows where and where not to send the traffic to. So it also look into the load balancing rule as well. Then we have container runtime. What a container runtime is? This is actually software which will run your your container. Kubernetes supports several runtime, but you can say the default on AK is Docker. The runtime is responsible for fetching the image, and it is also responsible for starting and stopping them. So that was pretty much for the container, for the Kubernetes architecture point of view. Till then, see you in the next video.